This is Unit 3 review. We were asked to figure out what dy over dx is analytically for this monstrosity of a problem. So we got to take this fella and we got to take the derivative of each of these terms with respect to x. So I'm just going to rewrite the problem, leaving some space for me to write dy over dx. So I got to take the derivative of the first term with respect to x, and the second term with respect to x, and the third term with respect to x, and the last term with respect to x. The derivative of 1/2 x squared, well, that is simply x. Because you take the 2 times the half, you get 1, subtract 1 from the exponent. It's the correct variable with respect to x, and that's an x, so that's good enough. This next one is quite the mouthful. We got to take the derivative of this, which is a product. We got the first factor and the second factor. The derivative of 1/2 x with respect to x is just a half. Multiply it by the second factor. Plus, we take the first factor, we multiply it by the derivative of the second one. Derivative of y squared is 2y. It's the incorrect variable because this is a y and this is with respect to x. So we put a little dy over dx beside it. The derivative of 6x with respect to x is 6 dy over dx. The derivative of 2x with respect to x is 2. Now the calculus that we just did, it's pretty easy. Finishing this up, maybe not so easy. Let's try to simplify this as best we can. Let's distribute this subtract sign, and let's also clean up some of this stuff. So we have x minus 1/2 y squared minus, distribute the minus, half times 2 is 1, so we got xy dy over dx plus 6 dy over dx equals 2. Now I think it's going to be in our best interest to try to get dy over dx by itself and then start substituting in. So I'm going to subtract this and add this to both sides so I can get these two terms by themselves. So I have a negative xy dy over dx plus 6 dy dx equals 2 minus x plus 1/2 y squared. I don't like this half in here, so I'm going to go ahead and multiply every term in this problem by 2. It's not something that you would have to do. I'm choosing to do it because I don't want that half hanging around. I think it's going to make my life a little easier. A little easier. A little easier. Now I can GCF out of the left dy over dx. And to get dy over dx by itself, we're going to divide both sides by this. I'm also going to rewrite it so that it's, no, I won't. I'll just leave it like that. So dy over dx is this ungodly thing. Let's assume I didn't make any mistakes. And if I know me, I probably have. We're supposed to put an x equals 4 into this, and that's not super helpful because we don't know what y is. But we can use this original equation, and we can put into it the x value of 4 and figure out what y is going to be when we do that. 4 squared is 16, half of that is 8. Half of 4 is 2. I'm going to move the 8 over here. If I do that, I'm going to get negative 2y squared plus 6y equals 0. GCF of this is, let's say, negative 2y. I'm going to give me with a y minus 3. So if I set each of those factors equal to 0, I'm going to get, unfortunately, two answers. Y could be 0 or y could be 3. So what does that mean for me? What does that mean for us? It means we need to evaluate dy over dx when x is 4 and y is 0. And we also need to figure out what dy over dx is when x is 4 and y is 3. Bummer. So let's do that. Let's do each of these. Let's figure out what dy over dx is when x is 4 and y is 0. It's going to be 4 minus 2 times 4 plus 0 squared over negative 2 times 4 times 0 plus 12. This is 0, this is 0. This is 4 minus 8, which is negative 4 on the top, and a 12 on the bottom. One of our answers is negative 1/3. So dy over dx, evaluated at 4, 0, is negative 1/3. Now let's repeat and figure out what's going on when we have the ordered pair 4, 3. So that's going to be 4 times 2 times 4 plus 3 squared over negative 2 times 4 times 3 plus 12. This is 9, this is 8, this is 4. So 4 minus 8 is a negative 4. Negative 4 plus 9 is 5. In our denominator, this is 12, negative 24. Negative 24 plus 12 is a negative 12. Not an impossible problem, but boy, the chance for errors in this, large, very large.